Hey, today we're going to go over lesson 12.1 about arcs and chords of circles. And we're going to start with some vocabulary. So the first one is about a central angle. A central angle is just an angle where the vertex is at the center of the circle. So I know the picture, it looks ovally. It's okay, it's supposed to be a circle. And just remember, center, central. They sound very similar. So they are the same. So when we have the definition of minor arc and major arc, we know major means something that's bigger, minor means something that's smaller. So when we're talking about this, we're talking about arcs more or less than like half the circle. So a half of a circle is called a semicircle. So how many degrees are in circles? Hopefully you're saying 360. So if it's half of a circle, let's go ahead and define semicircle real quick. A semicircle is an arc that equals 180 degrees, and this can be named by 2 or 3 letters. So when you have a minor arc, it's going to be less than 180 degrees. And minor arcs are always named with 2 letters. Now, when you're doing this, this is always the closest path to each letter. So if I say, look at arc AB, and there's always going to be an arc on top, so you know it's not a segment. Technically, I mean, you could go from A all the way around backwards to B. How do you know I don't mean that? Or do I mean this faster, more direct method from A to B, the green method? So since there's 2 letters, you know it has to be less than 180 degrees. So it means it has to be the more direct path. So just remember 2 letters, it's going to be less than 180 degrees, and it's a minor arc. So for a major arc, it means it has to be more than 180 degrees. And this is named by 3 letters. So if I wanted the big arc, let's go back and let's draw this in. If I wanted that big arc, you would have to start with each end point. And so I would start here with A, and I would keep going along this path, and then I would have to pass C, and then get to B. So I would say A, C, B, and put an arc on top. Now there is a variation because you could have started over here with B and went the other direction. So B, C, A. So as you can notice here, the first and last letters are the endpoints, like where you start and where you stop. And you just have to tell me a letter in the path. So what happens if there's multiple letters? So I'm going to add some letters. What if there's a D and an E and maybe even an F? You just tell me any letter along that path. You would have to say the starting point, which would be like A or B, 1 letter in between, and then the B. All right, so it's easier than what I'm probably making it out to be. All right, let's read the next one. SN and MT are diameters. So when it tells you it's a diameter, that means it's half of a circle. So that means it's a semicircle. So it has the measure of SPT. SPT, this angle over here, is 51. Now we know if the angle's 51, we know the arc is also 51. And if we know we have a semicircle, if we take 180 and subtract 50, which I believe is 129, that would be the measure of this big obtuse angle. Okay, so let's see how many of these we can figure out. Wait a minute, and I even forgot something. I forgot this one. NPR, let's find that. NPR. NPR is 29. Let's get rid of some of these lines. Okay, so that's 29, which means this arc is also 29. I know this arc is 129. And now we know that S to N is a semicircle, so that's 180. So I'm going to subtract 51 and the 29 to get what remains. All right, let me grab my calculator here. And I believe that is just 100, but I want to double check it. Yes, of course, that's just 100. So that angle is 100, which means the arc is 100 degrees as well. Now, is there a way to find this little yellow angle or arc MN? And of course, there's a way. Since we know it's a semicircle from S all the way to N, we know that's 180 degrees. So let's subtract the 129 and we're left with 51, which makes sense because guess what, guys? These are vertical angles. Okay, so we have all of the information. All we have to do now is plug the information in to all the answers. Find N to R. Now, in R, we're going to find the closest route here. And that is 29 degrees. B, find S to T. Well, we already did that. That's 51 degrees. Okay, let's find the next one, which is from T to S to R. T, S, R. So it looks like it's everything except this right here. So you have two choices. You could either add all the little parts and pieces together to get your total, or take 360, which is the full circle, and subtract away this yellow part, which to me that seems faster and easier. Okay, so let's get rid of some of these marks on the picture. And MST. Okay, MST. Well, that, guys, is a semicircle, and we know all semicircles are 180. So when we're dealing with circles, we have a tangent line. Now, don't be confused from the chapter with SOHCAHTOA, because if you remember, TOA is tangent, and which equals opposite over adjacent. This is a different kind of tangent. We just like the word so much in the math world, we have it to mean two different things. So when we're dealing with circles, a tangent is a line that touches a circle at exactly one point. So as you can see down here, we have this circle, and then we have this tangent line that comes through, and it touches at one spot, which is right here at R. So at that point, that's called the point of tangency. And I always joke and say something magical happens. It is perpendicular. It is 90 degrees. So point of tangency, 90 degrees. Okay, we have to know that because it's going to turn into a lot of Pythagorean theorem problems. And yeah, like I said, you have to know that. Okay, a line is blank to a circle if and only if the line forms a blank angle at the radius. Okay, so a line is tangent to a circle if and only if that line forms a 90-degree angle with the radius at the point at which it touches the circle. And that point, again, is the point of tangency. Okay. Now, this one, I give it a nickname, and I call this one the party hat theorem. All right, I'll show you why. It says if two segments are tangent to a circle from the same point outside the circle, then the two segments are congruent. The angles formed by these, the angle formed by the tangent line is perpendicular to the central angle. Okay, so this point right here at A and C, those are points of tangency again, so we know what happens. We know that forms a right angle. Now, over here, these two lines, these are considered tangent lines because they touch at one point. And if they extend and meet at this point out here and intersect, those two segments end up being equal. So these two yellow sides are equal. Now, why do I call this party hat? Well, good question. So if you turn this sideways, you can see a face, and this looks like a little hat somebody might have on. It's just an easy way to remember it because your party hat has to be symmetrical, otherwise it looks silly. Okay, enough about that. Now, what we're going to do now is we're going to find the measure of angles and the measure of side lengths. Now, on this picture, for example 1, it says, what is the measure of angle G right up here? Now, we have a point of tangency. It is at H. This line comes and it touches at one spot and it forms a 90-degree angle. So I can use the triangle angle sum theorem that says all triangles equal 180. And let's subtract away the 90 and the 68. So let's grab your calculator and subtract, and you should get 22 degrees, which is angle G. Now, part B says, what is the length of the radius? All right, where's the radius? The radius is from K to H. It's right there, which happens to be the same as right there where it's labeled R. Okay, so this is doable. We do have to use Pythagorean and FOIL. And I'll show you what I mean. Now, this side here, the full length is R and the 9, so we're just going to say it's R plus 9. Now, a radius stays the radius, so we know from K to H is also R. So if you look here, we have a triangle, correct? Yes. And we can do Pythagorean with that triangle. So we're going to find the right angle, which we have here at H, and across is the hypotenuse. So my hypotenuse is R plus 9, and we're going to square it. It's going to be equal to the sum of the legs squared. So one side is R, and I'm going to square it, and the other side is 12, and I'm going to square it. So we're going to go back to Algebra 1 for a moment. R plus 9 to the second power is really just R plus 9 times R plus 9. Do you guys remember how to FOIL this? Now, when you're in algebra, I know a lot of teachers do this box method. R plus 9, R plus 9, R squared, 9R, 9R, 81, and you add those together. So there's a middle term of 18R. Now, maybe your teacher taught you to distribute. R times R is R squared. R times 9 is 9R. 9 times R is 9R. And 9 times 9 is 81. Okay, so this is something we need to remember. And if you don't remember, relearn. So on the right side, R squared remains R squared. What's 12 squared? Well, 12 squared is 144. Okay, now I know this problem looks hideous, but you know what? something's going to happen here. We have r squareds on the left and right, and they both cancel. That's nice. So now what I'm going to do is I'm going to subtract this 81 over. So I take 144 minus 81 and get 63. Yes, 63. Then I just divide by 18 and I get 3.5. All right, so now I know my radius. My radius is 3.5. Okay, now moving on, it says find the length of the variable, or find the measure of the variable, I think would be better. Now, I'm going to find that big obtuse angle. Now, when you look at this picture, hopefully you see 2 points of tangency. I see one here that makes a 90, and right down here that makes a 90. Now, this right here is a four-sided polygon. How many degrees are in a four-sided polygon? Now, guys, we learned this a couple chapters ago. 4 sides, subtract 2 times 180. So that's really 2 times 180. And that is 360. That's your sum. So how do you find angle X? I'm going to take my sum and then subtract the 90 and subtract the other 90 and subtract 35. Okay, so let me grab my calculator and type this in, and I get 145 degrees equals X. Okay, now part B is going to be a problem like the part B up above here. So when you see this, hopefully you're seeing a point of tangency. It touches right here, and it makes a right angle. Now a radius stays a radius. So my radius here that I just outlined in blue is R. So that means the radius here is also, I said R, I meant X, is also X. So this length, X and a 1, is X plus 1. So when you have a triangle here, which side would be the hypotenuse? Hopefully you're saying it's right across from the 90, so it's X plus 1. And it equals the other two sides. One is X and the other is 3. And I'm going to square it all. Okay, so let's multiply out X plus 1 times X plus 1. And again, you can use the box method. You can do the distributive method. This is the method I always teach in algebra. X times X is X squared. X times 1 is X. 1 times X is X. And 1 times 1 is 1. Okay, now let's clean this up. When I add the two middle terms here, what's X and an X? It's kind of like saying what's an orange plus an orange? Well, that's 2 oranges. Here, X plus an X is 2X. Okay. So what's going to happen every single time is you're going to have a X squared on both sides and they're gone. So it turns into a much easier problem right away. So let's subtract 1, and 2X is 8. And lastly, divide, and X is 4. All right, so I know there's some steps here, but it's not something that, that's new. You guys have been foiling for years now. Okay, now we get to practice the party hat theorem. And see, you know what I'm talking about because remember the party hat. Now, the party hat theorem says when 2 segments come out and meet at an exterior point, those 2 segments are equal. So if on the right it's 9, that means over here on the left it's also 9. So let's change colors. Let's go down here and look at this 3. So if this bottom side is 3, that means this top green side is also 3. Now, can you tell me the length of that side there on the left? 9 and 3 is 12. So what we're going to do is we're finding the perimeter. So we're going to find all the different lengths, find the length of the sides, then add up all the sides. Now, do we already know everything on this side? We do. 3 and 2 is 5. Now, let's change colors. If this little side here is 2, do we know this little side right there? And we do. It is a 2. And do I know this little length here from B to X? Of course, because it's the same as this little length here, which is 5. So 2 and 5 is 7. Okay, now let's go ahead and add and find the length of A to B. So 9 and 5 is 14. So take your calculator and let's add all all 4 sides. All right, so 12 plus 5 plus 7 plus 14 is 38. And it's going to stay in inches because it's perimeter. Okay, so now's the moment of truth. Can you figure out how to determine whether or not this line is tangent? It's not that hard. What we're going to do, guys, is we're going to determine if it's a right triangle. And if it's a right triangle, that means there's a point of tangency, and the point of tangency only happens when the line is tangent. Okay, so we're going to do Pythagorean and see if it works. Now, here's the situation. And every year when I do this problem, I always kind of question it. Is this 12 referring to this entire length? Or is that 12 just this outside part? Because I could figure out this radius. This radius could be 4.5. Now, it's not super clear. On tests and stuff, I'm going to make sure it's super clear. Since this 12 is not centered on this exterior piece, I'm going to say that 12 is for the entire hypotenuse. Okay? So, if this is a right angle, that means the 12 is my hypotenuse. Now, I need to see if it's equal. It should be equal to 4.5 plus 10 and squared. So when I work this out, they should be equal. Now, we all know 12 squared is 144. My pen will work. And then 4.5 squared, I need to check. 4.5 squared is 20.25. So when I add these together, do I get 144? And the answer is no, of course not. Okay, so since it is not equal, okay, this is a big not equal, that means this is not a right angle here. This is not a right angle, which means this line is not tangent. Okay, so determine whether or not a tangent line is shown in the diagram and explain. Okay, so we're going to say, come on, computer. Okay, we're going to say no, it's not tangent. But why? Because the triangle does not form a 90-degree angle, which means the line, or which means the line is not tangent. Okay, hopefully you can read that. If not, I hopefully dictated that okay for you. And we are finished with notes. Please let me know if you have any questions or concerns about today's lesson. Thank you.